Today we're going to be looking at logistics growth. This is a very big field for us mathematically, and you don't even have to be a mathematician to understand how logistics growth works. Matter of fact, they use this quite often in animal control. If you work for the Fish and Wildlife Company or division of the government, you have to understand how populations grow. So what we're going to be looking at, for example here, we have a population of Ewoks. Now at the beginning of time, there weren't that many Ewoks, but eventually they start to multiply. Until something happens right here. Something is happening right here. We call that's our point of inflection. We'll talk about that in just a moment. Where the population is still growing, but it starts to slow down. Now, why does it slow down? Well, an environment cannot sustain an infinite population. So what happens is as the population of Ewoks starts to slow down, it approaches an asymptote, a certain number that the population will never reach. And we call this the carrying capacity. It's the largest that an environment or something can hold. And we see this all the time. Population. We also see this in the Olympics. For example, Usain Bolt can run the 100 meters in, 9.58 seconds. But eventually, there's going to be a number that's not going to be able to be beaten because you can't go 100 meters in 0 seconds. So there is a carrying capacity even in sports. There's only so much you can score or so fast you can run. Now, because the population reaches asymptotic, we can determine a lot about the growth of a population based on its graph. For example, where it changes, where the graph changes from being concave up, being exponential, to almost being logarithmic, where it goes concave down, we have a point of inflection. Well, what does a point of inflection tell us? Well, it's telling us this is where the population is growing at the fastest rate. So, go on to part 2, and we're going to take a look at some examples on how we can use population growth. I'll see you then. Bye-bye.